I'm from Japan, and I will give a talk about common shape puzzles. This is a joint work with these Japanese colleagues, and I'm Ryuhei Uehara from Japan, a mathematician of LDH number 2. And yeah, I also have LDH lap number 3, supported by long RAM. So if you need my lap, I will. Please use that. Okay, I will give talk about the common shape puzzle. Yeah, I remember. And maybe the first one will be the commercial product, which is sold as a tuples, which was on market in 2008. And actually, the Think Fun changed their name from the tuples to shapeometry and shape logic. I have no idea why. But anyhow, for this puzzle, you are given some problem. Okay, and each card, you have 2 colors of polyominoes. First one, this guy has an orange, 3 pieces of the polyominoes, and you also have 3 pieces of the polyomino in the blue ones. And the goal of this puzzle is making the common shape for these each 2 pieces, set of pieces. Okay, so in this case, this is a solution. You are given 3 orange pieces, and you are given 3 blue pieces, and you can assemble to the same shape. This is a solution. But actually, this puzzle is quite different from the usual packing puzzle. You feel something annoying because you have no clue about the goals, what the shape is correct. So you have no idea you are approaching to the solution or not. So this is very annoying problem, and even in the very few pieces, like 3 pieces. Maybe this is the reason why this puzzle is not so popular, but I love it. And another common shape puzzle is that sometimes which is called polyomino or polyform compatibility. This time, you are given, say, 2 polyominoes, this square and this T shape, and you'd like to form the same shape by using these 2 pieces. But in this time, you can make many copies. Okay. From the square, you can make many copies of the squares and make some form, which should be formed by the many copies of this T shape. Can you imagine that? Can you get the solution? So far, the smallest solution is this one. Wow. Pretty small. Yeah, and we have no idea this is the smallest or not. But anyhow, you can imagine that this puzzle is quite difficult. And you can find many such puzzles on the web, so you can enjoy that. But we have no idea they are smallest or not. So I investigate the theoretical difficulty of these puzzles. So this is a summary of our result. I don't give the details, but even if you do not use any copies, just only the making the 2 shapes without copies, this is NP complete, which means that this problem is intractable even if you use a supercomputer. It's very hard. And surprisingly, if you are allowed to use many copies of the shape, this problem is undecidable. I mean, you can't make any program which solves this problem perfectly. This is impossible, theoretically. But nevertheless, we make some solvers based on a SAT-based solver. We got some new patterns here. I don't give the details. You can find the details on the archive paper. But for example, this guy, we find this pattern. And the previously known result requires 760 ominoes. But we improve them to the only 160. And something like that, and something like that. If you are interested in such patterns, please check the archive paper. And to solve that, we use a SAT-based solver, which is a kind of useful tool for solving such a puzzle. And last G4G, I give a presentation about the reptile. You know, a reptile is a shape which can be filled by its many copies. And last time, we also used a SAT-based solvers. And inspired this one, I prepared some gift for this G4G15, which is based on the F shape. You know, F is 16 in computer. Okay, and actually, this F pattern is quite new. We found this one. Actually, this is a reptile of F, and which contains this weird shape. And this is the smallest pattern which can contain this pattern, and this one has the size 225, which means 15 square Okay. So I prepare the copies of this as a gift to you, like this. And I assemble this one by myself. And several hundreds, I know some hundreds. But I strongly recommend do not open to your home. Yeah, I practice a lot. So now I can assemble in only 9 minutes. But this is a world record. So you can't break it. Okay, that's it. Thank you very much.